In the last video, I showed how to create time-lapse videos on Prusa 3D printers using a camera controlled by a cable release and the Prusa GPIO Hackerboard. In today's video, we will replace the cable trigger with a wireless trigger. Before we start, I would like to say a few words. Everything you will see in this video, I bought myself with my own money. Nobody has any influence on the content of the video and nobody pays me for it. If you want to support my work, you can do so by subscribing here on YouTube, on my social media, and by sharing my videos. In this video, we will work with a product that is plugged into the printer motherboard and the camera. Improper handling can damage not only this product, but also the 3D printer. Everything you do is at your own risk. In this video, we will only look at wireless triggers that work on the principle of infrared light. So basically like a TV remote control. I wanted to look at the Bluetooth triggers as well, but their price was a little bit out of the budget for this video, which was originally $0. Infrared wireless shutter support can be guessed with the naked eye on the most cameras. In fact, you need a visible receiver on the camera to receive the infrared shutter signal. This is located on the grip of most cameras and looks something like this. Wireless triggers are the safest choice for your camera. There is no risk of damaging your camera as the camera is not electrically connected to the printer in any way. Before we start destroying perfectly functional shutter release, let's test them with the camera first. To be able to use a wireless shutter release, you need to enable support for the shutter release in your camera. On Canon cameras, for example, just go into the shooting mode settings and select one of the two modes with the remote icon. For Sony cameras, it's as simple as the competition. Just find the menu item for infrared remote control and enable the option. You will find a similar icon on Nikon cameras either directly on the camera body or in the camera menu. The rest of the settings are the same as in the previous videos. Infrared wireless triggers can be purchased at a very low price. I purchased several of them specifically for this video so I could take a close look at them and choose the best option. In idle mode, these triggers draw almost no current. The signal is only sent when the button is pressed. As a result, the batteries in them last for months or years. So there is no need to deal with an external power supply. You can find all these triggers on Amazon, AliExpress or Allegro, for example. You can find links to them in the description below the video. For all the triggers I tested, using pins from the open drain section of the Prusa GPIO Hackerboard worked. Therefore, I decided to connect all these triggers to the Prusa GPIO Hackerboard using a 2.5mm jack connector, just like in all the previous videos. So I will be using the black wire for common ground and the red wire for pin 0. My first thought was to get a universal wireless trigger and use it to show how it can be adapted to our needs. However, after removing the button foil, I decided that this would be too complicated a mission for most mortals. Yet I told myself that I would give it a try at least. Of course, before disassembling this shutter release, I figured out which button with the S symbol would work with my camera. The wireless shutter release is made up of a double-sided circuit board. On this side are just these buttons. All the electronics are hidden inside the shutter on the other side of the circuit board. Each button consists of two contacts that need to be connected to activate them. The button contacts are connected to the other side of the circuit board using these pins. Using a wire jumper, I transfer the information where the wires going to the Prusa GPIO Hackerboard would need to be soldered. After unscrewing the board from the trigger case, this jumper gave me a nice view of where I would need to solder. The wires for the Prusa GPIO Hackerboard will need to be soldered to these connections. For the Canon R5C, I had the advantage of having one side of the button connected to the common ground of this shutter release. This made the wiring perfectly simple and there was no need to test anything. I connected the black common ground wire to the contact that is connected to the common ground. I connected the red wire of pin 0 to the other contact of the button. I then reassembled the remote trigger to its original state and tested with my Canon R5C. After seeing how complicated this universal wireless trigger was, I decided to focus more on brand-specific triggers. After all, they don't need as many buttons on them. So I purchased this shutter release for Sony cameras. After taking off the button foil, I felt like life was playing a joke on me. As with the previous shutter release, I used a wired jumper to transfer information about the locations to which the wires going to the Prusa GPIO Hackerboard would need to be soldered. As with the previous trigger, I decided to solder the wires directly to the main chip contacts. After testing the trigger, I had to swap the wires between each other to make the trigger work with the Prusa GPIO Hackerboard. I then reassembled the remote shutter release to its original state and tested it with a Sony a7R3 camera. From the same seller on AliExpress, I found these miniature wireless triggers. These have only one button on them and all have an identical look. Here is a wireless trigger for Canon and one for Nikon for comparison. The previous triggers had the circuit board bolted on. These mini triggers have the circuit board glued where the battery is located. So the board had to be carefully ripped away from the trigger case. I used a small flat file to do this, but you can use whatever you have on your hand. As you can see, there is not much on the circuit board. Plus, with only one button, it's more than clear where you need to solder the wires going to the Prusa GPIO Hackerboard. The top contact goes to common ground and the bottom contact to pin 0. If you don't want to stick the wires on these contacts, you can again solder them directly to the main chip contact. This is what I eventually decided to do. I then glued the circuit board back into the trigger case. After that, I reassembled the remote trigger to its original state and tested it with my Canon R5C. If I had to choose one of the wireless triggers I tested, this last model would win. Aside from the need to glue the circuit board back into the case, this trigger was a piece of cake. As a bonus, this shutter can be purchased for a large variety of camera manufacturers. The main disadvantage of infrared wireless triggers is that they must be able to see the signal receiver on your camera and nothing must obstruct that view. Probably the easiest solution is to get a longer cable connecting the wireless trigger to the Prusa GPIO Hackerboard or an extension cable with a 2.5mm jack and 4 pins. It just depends on how you have these two components connected. You can then place this trigger on the right side of the printer, for example. In my case, for example, the trigger gets a perfect and unobstructed view on my camera, which is always on the right side of the printer. Let's take a look at the slicer settings. Most of the settings have already been explained in the previous videos. I recommend you to take a look at them. We will use the configuration from the last video. Since we are only using pin 0, we can delete everything around pin 1. So there is no need to set pin 1 as output or change its state. That's all the changes needed in the G-code. If you have done everything correctly, just set up the camera as shown in the previous videos and you can start capturing the printing process. You can use DaVinci Resolve to convert the captured photos to a video, as we also demonstrated in one of the previous videos. Since, judging by the number of views in this series, no one is interested in these videos, I decided to focus on videos with a different topic for a while. I'm not sure if it's the fact that these are videos focused on time-lapse videos, or the fact that these are videos featuring Prusa products. Please let me know in the comments what you think.